So hello, my name's Ryan Simpson. I'm from Microsoft, and I'm joined here today with Jeremy from Hitachi to discuss optimizing support and beyond with chatbots. Jeremy, did you just want to say a quick hi?
Hi there, yeah, my name's Jeremy Herbert. I'm a solutions architect at Hitachi working in the bot space.
Excellent, thank you. So what I thought I would do is just do a little bit of scene setting and position or explain the way bots are being positioned in the marketplace, and look at the capabilities that the Microsoft stack brings to that positioning, and then look at the tools from Microsoft in the context of that positioning. Then I'll hand over to Jeremy to explain how they've built out several solutions using these tools. So this is not an unusual question. Why now is seems to be repeatedly asked, but for me there is a difference in the why now, and that difference falls into firstly the way that we're delivering artificial intelligence. So you may or may not be aware that Microsoft has now packaged up and made much more consumable some of those higher level services which traditionally would be much harder to get at. So natural language processing, sentiment analysis are now not only directly consumable through REST APIs, but they're also easier to train, and we'll talk about how an appreciation of machine learning is all that is required, rather than a depth knowledge of machine learning in order to consume these services. We know, and we've known for the last 5 years, that not only are volumes of data prolific, but the big change that happens or is happening right now is the way we're able to package and consume data services such as NoSQL databases, Cassandra, MongoDB, relational stores, Spark. We can deliver those in a platform like Azure with a very few number of people, and combine those together with these these packaged artificial intelligence services really rapidly. We can get to the day job of interpreting and processing data much faster than we could a few years ago. And then the evolution that we've pushed into with conversational platforms, and I'd like to drill into that timeline just a little bit more because it is an important story. So back in the 1980s, the Microsoft vision of a computer on everybody's desktop was an admirable objective, simply because the way that we consumed services was very linear. It would be a linear flow through a form. The shape of the service that you'd be consuming was delivered to you through software. With the advent of the web and search engines, we were able to introduce an almost self-help experience for customers. They could connect to your website, they could browse for specific information. With the advent of smarter search engines, you might optimize your site to take a user into an FAQ so that they could help themselves before they picked up the phone to you, which would save them time and it would save you time. Then with the advent of the iPhone, we saw the app culture begin, and the app culture really extended some of this Web 2.0 stuff by giving the same capabilities of web, but also allowing us to enrich that capability by bolting extra functionality that you couldn't rely on from a web-delivered platform through an app. Plus, it made it much easier to capture user behavior and to maybe start to think about how you might adapt the way that you interact with users. But we're still in that world of request response, predetermined flows through forms, and even with the concept of kind of chat agents back then, we were still looking at a decision tree type approach to handling conversations. And now we're in this world of the conversational user interface. So it's not unusual for an end customer now to expect a dialogue with a service. We've seen the push last year with Siri, Cortana, people are no longer surprised when their devices have become pseudo-intelligent, and it's that conversational UI that I'd like to just drill into in a little bit more detail, so that we can understand the shape and delivery style of the bots that we can produce right now. So what I've put together is an arbitrary scale. The horizontal axis represents smartness, and what we would consider is that a device or service on the left is less smart than a service on the right. So if we look at maybe the first level of interaction, so previously in self-serve it might have been an FAQ, and my own experience of this is recently with a streaming service. Video wouldn't stream, punched a why isn't my service streaming into a search engine, and found the answer on the FAQ. I didn't have to phone a support desk to get some advice and guidance. So we have tools to very quickly produce these these bots, and they're very rudimentary. I might refer to them maybe as pseudo bots. They're able to take a question and give you a point and discrete answer. The sort of skills that you are looking for to deliver these is essentially web app development, and then an appreciation of machine learning. So by appreciation, what I mean is that you don't need to be able to develop at depth the machine learning model. You just need to know how to guide it with the data that you're supplying to that service, and then accept that it will do its best to learn. It's a very non-linear process, but we'll see some of that in action. And you could deliver a simple Q&A bot with literally one or two web developers out the gate right now. So if we then start to increase the smartness of the bot that we're trying to deliver, we get into probably the ballpark that people are starting to think more about, which is the semi-intelligent chatbot. So by semi-intelligent, what I mean is that the bot is able to have a dialogue with a user, so there's some concept of state in there. It's also able to deal with multiple use cases, but we wouldn't expect it to deal with use cases we hadn't developed it for. So things like talking a user through providing data to submit a support ticket would fall very much into this this area. Again, we're still in the world of, we just need to be able to appreciate how we guide a machine learning model. We don't need to be depth practitioners of machine learning, deep learning. And again, the service is just essentially it's a web app, and without being too disparaging. So the way we would host a web app is the skill set we're looking for. And again, with Azure, there are platforms specifically for hosting these stateful bots capable of holding a dialogue and interfacing with other systems. So we would expect the skills required to push or develop these would be a slightly larger development team. You're likely to have a combination of web app, application integration, and data people, and hosting skills. So not beyond the realms of possibility. So over on the right hand side, what we've got is the virtual assistants, or the fully intelligent assistants. So these are really the Cortana or the Siris of the world. And the dialogue, sorry, the image we've got there is for a bot developed by Airbus. It's in trials at the moment. It's called Simon, CIMNAN. Its role is to be a virtual assistant to scientists on the International Space Station. So it's a very intelligent assistant. It's able to take on new tasks that it wasn't prepared for, and it's really that sort of HAL 9000. And when we come to develop those agents, you are looking at a significantly broader and deeper team. So web app developers, application developers, and then we move beyond the appreciation for machine learning and into the world of actual deep learning expertise. And by deep learning, we are talking RNNs, or recurrent neural networks, that style of learning. And then on top of that, the ability to host all of those components. So no longer just hosting the web app and the the integration services, but hosting the machine learning models that will be repeatedly and constantly trained in order to deal with learning new and relevant skills. So you can imagine that the team is exponentially bigger, and the projects are substantially larger than these projects. So the two bots we're going to look at today really are on the left hand side. So the Q&A bot and the stateful chatbot. So the way, or what have we got in the stack that can deliver these capabilities? So Microsoft is a very big space, and following this axes approach on the left hand side, we have the fully packaged good to go Cortana. Then as we move sort of left to right, we're getting closer to the metal. So we have software as a service on the under applications. So stuff you are going to consume, Office 365, CRM, Dynamics, etc. But then in the middle we have for the services that you can use to build your own bots. And the three that we're going to focus on today will be the Q&A Maker. So Q&A Maker is a web-hosted no-code solution to developing out those simple FAQ answering bots. We're then going to add a little bit more intelligence to it by consuming the language understanding and intent service. So again, it's web-based, but the beauty about this service is from a very small number of samples, it will have it'll provide us with a capability to guess what the user's actually trying to achieve. And then we'll look at the bot framework. So this is a free NuGet delivered package that allows us to build the plumbing to bring these services together to build a stateful bot that can handle a more complicated task, such as raising a support ticket. So without further ado, let me dive into a demo. So moving into the Q&A bot. Q&A bot is available off a single URL. Actually, we'll just keep that URL in my buffer. You'll see why in a second. So QAmaker.ai, and all I'm going to do is create a new service. So right now this service is free. For your free service, you can handle, I think it's 2 requests a minute, up to 10,000 a month. What I'm going to do is just name a service as FAQ4, and I'm going to give it an FAQ to go and explore. So maybe I should show you the FAQ. Cool. So this is the FAQ for the Q&A Maker, and you may have something like this already in existence. What the tool will do is parse this page into question-answer pairs, and it will store them in a tab-separated value file referred to as an internal knowledge base. So let me do that now. So this is literally all the information I need to provide this service. So it's going to attack the FAQ, parse it, and produce exactly that Q&A pair. So now I can go work with this FAQ again, I'll call it pseudo bot style, but to my external user, you're going to see hopefully that it's still very much a bot. Now I also mentioned that you need to be ML aware. So for us, what that means is that we are looking for a response to these questions. The response is on the right hand side. The way we're going to guide this ML model is by providing examples of questions, and I'll be repeatedly using save and retrain, and you'll see that it really doesn't take very long at all to do this. So let's go test our bot out. So it's already sent a hi, but just to sort of demonstrate that it's absolutely stateless, it doesn't care how many times I'm going to send hi into this service. all we are doing is issuing a REST request and we're getting an immediate response back. There is nothing stateful about this at all. So let me go ask a question that I know is explicitly in the question pool. So how safe is my data? No question mark, but it's obviously let me off on that, and it's come back with a a direct answer for all knowledge content is stored, which we know is in there. I can't see the word safe in there. It is in there, I promise you. But what I want to demonstrate is that we are doing more than just a keyword lookup. So what I would like to demonstrate is that we're doing more than just a keyword lookup. So what I'll do is instead of asking how safe is my data, let's go and ask how private is my data. So the same question, just in a slightly different term. Cool, and I've got a contextually accurate answer back, and part of this tool is also providing me with these are the other responses that that might have been appropriate. So let's drill into that capability right now. So we'll ask another question. How much is the service? So again, it's an explicit question that we know exists in the knowledge base. So let me ask it in a slightly different way, in a more natural way, which is how much is the Q&A maker? Okay, so by luck, it has come back with the actual answer. But how about if I just say how much is the Q&A maker? How much is the service? Let's not give it any. Let's not give it too many clues. So what we can see now is that actually it has come back with something inappropriate. It's got how. My guess is that it's found how and service, and it's the nearest match I've got is, or the best match I've got is, this is how you deploy your service. Whereas the response I actually want it to do is this second guess that it's got, which is the Q&A maker tool is currently free. So I've guided it by selecting the appropriate response. What I'm going to do now is just save and retrain that model. And now if I ask how much is the service, it comes back with the appropriate response. And when I go into the knowledge base, you can see that question has been added with the appropriate response. So there's a nice way for me to guide the knowledge base. All of the items, all the actions I'm performing through the UI are accessible via an API, and I can also I can download the existing knowledge base as a TSV file, and I can also upload existing question answer pairs. So how do I consume this? You aren't going to give this test UI, so it's very simple. From this UI, when I elect to publish the latest version of this service, Q&A Maker will host this model for me with a REST endpoint, and this is the only call I need to make with this subscription key in order to poke Q&A Maker and get a response. So I can consume that from my mobile phone, my web app, my web page, or I can use this as one of the services within a more complicated chatbot. So we saw a very simple example of how we might be able to guess the intent of the user by looking at a different way of wording the question. We have exposed that ability to you via the language understanding and intent service. So that service is it's available to you right now under Lewis.ai, and just to show you what it's capable of, I'm just going to show you using this UI, me interacting with it. So in this instance, I'm going to provide some free text to the service, and it's going to return an intent, and that intent will be something to do with turning a light on or off. Now, it's important to note that the language that I'm going to use is free text. So if I say turn on the light, we can see that it has got a 95% certainty that the intent is this free label turn all on. So if my application is looking to differentiate between turn on one light and turn off one light, then it will do that. So we can also demonstrate that with turn off the light. Now again, this is non-linear. It's come back with nearly 100% certainty that the intent is turn something off. What if I use something that isn't directly turning on or turning off a light? So I might just say flip the switch. Excuse me. So in this case, it's come back with, flipping the switch. It thinks it's only 44% certain that the goal here is to turn all on. So maybe what I'll do is, in my response, is just say flip the light switch and see what it comes back with. So the confidence is going down more and more, but what we'll do is we'll just maybe we'll give it a fighting chance, flip the light switch on, so what, 30% chance that it's that we want to turn something on. So what we're seeing here is that by using statements that I haven't already armed the engine with, it will still have a go, and it's telling me how confident it is, and later on we know that we can retrain the service with these utterances because they're captured. So what I've set up is there is we've got a small help desk bot. Its goal will be to help a user create a support ticket, and we're going to use a Lewis model to detect that intent. So what I've got set up here is a Lewis pre-built Lewis model, and it can do a number of things, or it can detect the desire to do a number of things. And the one that I'm interested in is the intent to submit a ticket. Now I've already given it some clues as to what sort of statements might require a support ticket. That model's then been trained, and I've used the bot framework to build this into into a small end-to-end solution. So the code I'm about to show you is publicly available on GitHub, and I will share the links to these resources at the end of this session. All I need to do is take you to this application. So this is essentially a web application, and I've installed the bot framework. Bot framework is available as a NuGet package, and it's the bot.bot builder. And what that gives us is the software plumbing to automatically bind to a Lewis model, and then the plumbing to have a conversation flow just by daisy chaining methods using delegates. So what is going to happen is I've got my bot emulator down here. We'll fire that up in a second. You can see that this application is bound to, and these are the application keys to get into my Lewis model. When we come in, we'll get some dialogue, and then the bot framework will handle capturing and passing us between this information. So I'll just restart this conversation with a hi. And you can see straight away that it has dropped me into the starting dialogue, and all it's going to do is actually nothing. It's just started a conversation. It's waiting for the next I guess activity. So I'm going to come back now with just some free text. It'll be something like, I can't log in, I'm blocked. So what we can see here now is that it has correctly identified that this is probably something that would require me to create a ticket. So it's built up some initial initial state. It's having a go at finding those you may have spotted the category and severity, but the next thing it's going to do is redirect me to this next method, which will build up a support ticket. So let me resume this code. So now it wants to step me through creating a ticket. So I'm going to say this is a security problem, and we are now in the next method down, which was ensure ticket. So we'll just carry that on. And the application has enough information to bring a support ticket together. So it's a high severity in security, and it's going to use the initial text that I used. And the layout here is using a card from the bot framework, which works both in this and web UIs, and it's created that ticket for me with this this nice little bot icon. So that was a very, very rapid fly through looking at the two types of bot, starting with Q&A and then coming across to a chatbot using the Q&A maker, relying on the Lewis service, and then bringing it together with bot framework. So what I'd like to do now is hand over to Jeremy to explain how Hitachi bring this together.
Cool. Thanks, Ryan. So I'm Jeremy, work on the digital team as a solutions architect, and I'm joined by Stuart Reeder today as well.
Hi everyone, thanks for joining us, and thanks Ryan for that introduction. Hitachi Consulting are working with many industries to digitally transform business using conversational solutions such as the bots that Ryan has presented today. And those industries can be everything from educational institutions, retailers, and financial services organizations. And we have use cases across all of those verticals, both for supporting internal processes like the support ticket model that Ryan just introduced, but also external business processes like improving customer engagement. And Jeremy now will walk through some of those examples with you.
Cool. So I just wanted to walk through some examples of bots that Hitachi have built and are working on at the moment. The first one on the list there is the customer service bot for a leading pizza delivery company. So in this scenario, the customer came to us with the problem that telephone ordering and the website wasn't reaching all customers on the different channels that they're now communicating on, that they were facing rising competition from services such as Just Eat that's sort of cutting edge. And they needed to engage via the channels that consumers are now using in the sort of pizza space. So the solution we built with them was in collaboration with their development team. It was a bot that was made available via not just the website, but also through Facebook and Amazon Alexa. And it had a defined number of actions that you could perform against it. So you could view menus, you could order the pizza, you could track the delivery. And it also had a lot of back-end system integration. So it's an example of a bot that is relatively straightforward and simple, but delivers an awful lot of value for the customer. There are a number of other examples of bots that we've built. So Q&A bots, one we're engaged in at the moment, a study planner bot for a university partner network, and also our own solution that Hitachi are offering, Insurance in a Box, that combines bot and back-end third-party insurance platform. I just want to run through those in a little bit more detail. So the first one here, this study planner course comparison bot for a university partner network, is something we're currently in discussions with a customer regarding. And basically their business problem was the organisation has a network of partners that place students in universities worldwide. So for example, one of the partners might have a potential student coming to them that wants to study economics in the UK, and it's down to the partner to be able to access all of the information that's available to them to place that student in the right university on the right course. But accessing information for partners is time consuming. It's typical web forms with back-end databases, and it's difficult to find more direct information other than going through very long-winded steps, and often a lot of manual scanning of web pages to find the right course for the student. So what they wanted was a bot that could help their partners access information directly, and that information may be held in a structured and unstructured way, so in a database, as well as lots of unstructured information around those courses. So in the first instance, we leveraged a Lewis model, so as Ryan went through previously, putting together a model of what the bot will understand and how it's going to interpret it, and matching what the partner actually wants with an outcome or information. So we made use of Lewis, and it's not just about identifying sentences and directing the user to the right information. In those sentences, we wanted to identify what it was they were looking for. So we could take a full sentence of, I have a potential student who wants to study economics in the UK undergraduate level, and we can pick out the fact that they are a student, the subject they want to study is economics, and the level they're looking for is the undergraduate level. And we can bypass all of those sort of web form interfaces that are quite long-winded to get to that information, and take the partner there directly. And another element that was quite interesting is the FAQs. When you're asking the bot a more simple set of questions and you just want an answer, we don't necessarily need to drill into course information. We've got the Q&A maker that Ryan went through previously, but also we're able to synchronize internal repositories information that aren't necessarily exposed externally into the Q&A maker service. So you can actually bring an awful lot of information in there, let the Q&A maker do its analysis, its natural language processing, to reach answers for that user. And so this idea of context that I've kind of explored, that it's replacing step-driven forms and filters, that as you're having the conversation with the bot, that it's building up a version of that form in the background as to what it is the student potentially is looking for, and sort of builds up that context so you reach a more accurate result, but the partner doesn't have to worry about, have I completed all of the form fields? That's all managed in the background, and it becomes more like you're talking to somebody as opposed to just filling in a form. And one of the benefits, obviously, of this solution is a reduced conversion time from question to answer, that you're not taking time to fill in forms, that you can go direct to the information that's relevant and connect that student with the correct course. And also all of this is surfaced through a partner portal, so it's important that authentication was factored into this, that when you're logging into that partner portal, that you're authenticating to the bot, because a lot of the information this organisation holds, it's private to that organisation, it isn't made available publicly. Okay, also a data-driven question and answer bot that we built for a multinational health and hygiene power brand. So ultimately this organisation had invested a lot of time and effort in revitalising their back-end data system, so bringing a lot of sales data through a lot of the Azure services that are available, and having this sort of repository and way of reporting that they wanted to leverage and make use of. And one of the troubles was that there are a lot of reports, a lot of ways to access information, but not necessarily a direct way for individuals to reach what they're actually interested in. So it was a sort of manual exercise to figure out which report, which metrics, etc. they wanted. So they were after a bot that could actually drill into that information really, really quickly, presenting execs or other employees with the information that was most relevant to them. So you can see the example on there, what was the total invoice value for product name on date. These were the types of questions that they wanted to use and run against those data sources in the back end. So we were leveraging the Lewis model and taking that a step further to the point where we could identify entities within sentences and map those to what were ultimately queries in the back end to return the correct data. So invoice would be an entity, so what is it you're actually looking for? Product name, another entity, and date. So in the conversation those would come through, we'd identify those, and then that would form part of the query. and it's something that in the future potentially we can put more services in, like the Power BI query language, to improve that, as well as things like text analytics. Okay, and then lastly, I wanted to run through the Hitachi solution, the Insurance in a Box, and just running through some of the features of that solution, just as an overview. Ultimately, this is to help customers sort of get quotes and buy policies from an insurance provider. And if we run from left to right, we've got the users, the customers interacting with web chat. So that's part of the bot framework, allows you to embed bots within existing web applications, be that internal or external, and also Facebook social channel that we can expose the bot onto. And that's not the only channel. There are multiple channels that Microsoft is sort of making available as time goes on. And then moving on, we've got the Azure Active Directory business to consumer service being used. So something that organizations are shifting to manage the identities of their customers is the business to consumer service. And what this allows us to do is customers can sign in using their Facebook account, whichever social account, or their Microsoft account, or a number of different accounts, and we can use that to identify them through to our back-end applications. And then also in the middle, we've got the actual bot service itself. But an interesting aspect of this solution is that we can go to a live operator. So in certain scenarios where we're potentially interpreting that there's negative sentiment, so using some of the cognitive services available from Microsoft, detecting that actually the customer is better off going to a customer service representative, or potentially if we are triaging those questions and then wanting a customer service representative to take over at that point, we can do that also. And we can integrate with the likes of CafeFX or some of the Oracle help desk solutions that are out there. And this basically just means that your bot isn't responsible for trying to resolve everything, that there is potentially room for human input, an element of human assistance there to help out the customer. And obviously with this particular solution, we're still taking advantage with Lewis model, so identifying what it is that the bot should actually answer and allow customers to do in terms of actions. And again, we're hooking into the Q&A maker service, and we can synchronize on-premise repositories of data, so question and answer sets, into that service, so that the more simple actions that customers want to perform, or the questions they have, can be answered. The more complex ones are potentially things like getting a new quote, renewing your insurance, or potentially making a claim. Those kind of actions can actually be serviced through the bot, and they would go through to the insurance API and the back-end insurance software to actually process those, and potentially for brokers they would create to-do items they would actually service. And those are just some of the points that I've covered already. And on that note, I'll hand back over to Ryan.
Cool. So thank you very much. So a huge thank you to Stuart and Jeremy for the time. Just to sort of reiterate what we covered. So we looked at some very simple, referred to it as pseudo bots. So the Q&A delivered using Q&A Maker, which we were then able to use the Lewis service to enrich and then bring together with the bot framework. And then again, thanks to Jeremy and Stuart for showing us how we can bring those together for a much more accomplished set of value add bot services. Thank you again.